All right, guys. I apologize. I have not been able to figure out why this is echoing so bad. I will still try to kind of get an answer so that hopefully you don't have to have too many more videos with the annoying echoing in the background. But we'll make do until then. So the second lesson in this unit is finding the area of trapezoids, rhombuses, and kites. And so we're going to start with a trapezoid and just kind of review some of the characteristics of what a trapezoid is, and how we'll identify the different components of a trapezoid. All right, so remember a trapezoid is a quadrilateral that has exactly one pair of parallel sides. Okay, those parallel sides are always going to be the bases. So that's what these mean right here, base 1 and base 2. And then the height of the trapezoid is the segment that's drawn perpendicular from one base to the other. And so you could draw the height in here, you could draw it in here, you could draw it outside of your trapezoid like we did with some of the parallelograms. It's just perpendicular distance from one base to the other base. The way that you find the area of a trapezoid is to find 1/2 times the height times the sum of the two bases. So essentially this half, if you think of it like right here, it is the average of the bases, essentially, kind of like when we did mid-segment. All right, so this first example is looking at the state of Nevada, and we're going to find the approximate area of the state, right? So this state is actually a trapezoid because we've got this side and this side right here that are parallel. So if we turn our paper this way, this would be one of our bases, and that would be the other one. It doesn't matter which base you call which. Okay. And so then it looks like here is my height, the distance from one base to the other. So this one's kind of nice because I have everything that I need in order to find this area. So when I just substitute everything into this equation, it's 1/2 times the height times the sum of the bases. So 205 plus 511. And once you've got all that, you can really just type this whole thing right into your calculator. So instead of typing in the fraction, I'll use the decimal. 1/2 times 309. Just make sure you put this sum in its own set of parentheses. Okay, so if you'd rather find that sum first, so maybe you do like 205 plus 511 and make this just one extra step so you don't have to worry about whether or not you're typing it in right. That's never a bad idea. And then times 760. And then you can just type everything. 1/2 times 309 times 716 is going to be 110,622. And then remember, anytime you're finding area, you're always going to be in whatever units you're in, square, because we're always multiplying with feet times inches times inches, etc. And so this would be square miles. Okay. Now, these next couple are kind of extensions and applications, bringing back some of the things we did in the last chapter in terms of special right triangles. And so what we know in this one is find the area of the right trapezoid, so kind of like a right triangle. When you know that it's a right trapezoid, that means that it's got at least these two right angles right here and right here in order for these to be parallel. So we know that we've got our bases, but we need to figure out what our height is, which we don't know. And so we have no way of knowing this length or this length using only the 5 and the 7 that we have. So what we're going to do is draw our height in right here. I'm going to draw that segment perpendicular to the other side. And now what I've done right here is I've created a right triangle. And it's a 30, 60, 90 triangle. Okay, and so what we can do from here, I'm going to actually draw this triangle separately out here. Take a little bit more space. So we know that our 60-degree angle is right here. That would make this our 30-degree angle. And so when we drew that height down, we created a rectangle and a triangle. And so we can say, well, if this is 5 centimeters, then this side also has to be 5 centimeters. And if this whole base is 7, meters, not centimeters. If this whole base has to be 7 meters, then that leaves this to be 2. And so that is what we consider the short side of our 30, 60, 90 triangle. And I only want the height. I don't really need to find the hypotenuse. It's just not needed in this particular problem because I need the height in the equation for the area, which is this segment right here. And so remember, the relationship is that the long leg, which is across from our 60-degree angle, is radical 3 times as long. So when we go to find our area, now we've got everything that we need. So it's going to be 1/2 times our height, which is 2 radical 3, times the sum of our bases, which would be 5 and 7. Okay. So I'm going to go ahead and add those two bases together. So 1/2 times 2 radical 3, 5 plus 7 is 12. Now, just a quick review in terms of multiplying when you've got this radical involved. You essentially are multiplying like parts together. So anything that's under a radical, you would multiply together. Anything that's not under a radical, you multiply together. So the 1/2, the 2, and the 12 are not under a radical. So I'm going to multiply those three numbers together. 0.5 times 2 times 12 is 12. And then, since I don't have anything else to multiply the radical 3 with, it would just be 12 times radical 3, and then meters squared. We are going to be practicing making sure everything is an exact answer as opposed to the approximate. Whenever we can get an exact answer, that's the absolute best you can get. It's much better than an approximated version of it. So always give the exact answer when possible. All right, so now we are going to kind of do the same thing here in this one. We've got this other trapezoid. Now here I've got essentially 2 unknowns. I know that this is one of my bases. And here's my 2 right angles. I don't know this either. I also don't know the height. But when I draw in that height, a perpendicular distance from one base to another, I've again created a special right triangle. So I'm going to draw that out to the side. So here's 30. My hypotenuse is 10 degrees 10 centimeters right here. Okay, so now that's the hypotenuse. This would be the short leg, and this would be the long leg. And so now here, if we want to use this to figure out, we can use this to figure out the length of this base as well as the height. Because if this whole distance is 14 centimeters, if I can find what this distance is, then I can figure out what this missing part is, and that would be my other base. All right, and so if I know that this is 30 degrees, let's see, I already said that's my hypotenuse, so that means my short side would be 5 centimeters. And this would be 5 radical 3 centimeters. So those are the sides of the triangle. Okay. And so if this distance right here, from here to here, is 5 radical 3. So think about kind of what we did here. We knew that this whole thing was 7 and this was 5, so we did 7 minus 5 to get this. This is the same idea. It's just going to be a little bit trickier because we're going to have to subtract that radical. So this side is going to be 14, the whole distance, minus the 5 radical 3 from that triangle. Okay, so that's going to be this side as well. So the multiplication is going to be a little bit trickier, and we'll work through that as well. So my area, I'm going to substitute everything in now, is going to be 1/2. The height we found, I just kind of matched it here. That height is going to be 5 centimeters. And then the bases are going to be 14 plus 14 minus 5 radical 3. And so what we'll do is combine like terms in here first. We can only combine just kind of like with the multiplying, we only can combine actually like terms. So that 5 radical 3 is not a constant, only the 14. So that's going to be 1/2 of 5. 14 plus 14 is 28. Minus 5 radical 3. And so, unlike this, where we multiplied the 1/2, the 2, and the 12 together, because we've got multiple terms in here, we are actually going to need to do the multiplication now in a couple of steps. So the first thing I'm going to do is just take the 1/2 times the 5. So 0.5 times 5 is 2.5. And then I've got 28 minus 5 radical 3. And so then what we'll do is we will distribute that 2.5 to both of these terms. And then that will be our final answer. So 2.5 times 28 is 70. And then hold on a minute. Negative 5 times 2.5 is negative 12.5. And so it's kind of a messy looking answer. And this, guys, is like absolute worst case scenario. You should not have any problems that are more difficult than this one. But I just wanted to give you kind of at least one in the notes that you could refer back to if you run into something like this. Now you will have problems that are probably more along these lines, where you're still multiplying with radicals, but you should not have too many that involve like the adding and subtracting as well. Try to keep it at least like medium to difficulty. All right, and so that is it for the trapezoids. And so now we're going to move to the kites and the rhombuses. So before we get started with the formula for the area and then just looking at some examples, I just wanted to review some of the properties of rhombuses and kites. So remember that if you are looking at a rhombus, diagonals are always perpendicular bisectors of each other. Okay. Excuse me. So that means that you'll have that right angle in the middle if you're looking at a rhombus. So that creates right triangles. That also is going to bring back possibly 36 to 90 as well as Pythagorean theorem. And then in a kite, remember that the shorter diagonal is bisected by the longer diagonals, and then the diagonals are also perpendicular. So what that means is that since this is the shorter diagonal right here, this segment and this segment are going to be congruent, and then you've got that right triangle, 4 right triangles in there as well, so that may help you find missing pieces. So the formula for the area of a kite and the formula for the area of a rhombus, it's the same formula. It's 1/2 times each diagonal. So 1/2 times D1 times D2. So in these problems, you don't necessarily need to know the side lengths. You just need to know the lengths of the diagonals. Oh, I'm kind of going back here. When it says that they're perpendicular bisectors of each other, that means that this and this are the same, and that means that this are the same, and this are the same. They're not necessarily all congruent, but they are each little diagonal is cut in half. All right, and so if we look at this first example right here, we need to know the length of each diagonal. So we're going to use properties of rhombus to kind of make that happen. And so if we know that this is 3, it's pointing to that little segment right here, then that means that this is also going to be 3. So one of the diagonals is going to be 6 feet. And then if this is 5, then this is also going to be 5. So that means the other diagonal is going to be 10 feet. And so if I want to find the area, then I need to take 1/2 times 6 times 10. Now you're not distributing the half to both of these. It's not 1/2 times 6 plus 10. You're multiplying all 3 of these together. So I would just type this, since you don't have to add anything, just type it all in at once, and you'll get 30 square feet. All right, so here's an example of a kite, and remember, you'll know the distinction between the two, because a rhombus has 4 congruent sides, so we can see that here, and a kite only has 2 pairs of congruent sides. So we've got these 2 marked the same, and these 2 marked the same. Now, luckily, there's really nothing that we need to find in this one. I just kind of organize everything here. One of the diagonals, 10 plus 10 is 20. 10 plus 10 is 20, and then 10 plus 20 is 30. So the length of the diagonals are 20 meters and 30 meters. And so the area is going to be 1/2 times 20 times 30. And so when I type that all in, I get 1/2 times 20 times 30, and that's going to give me 300 meters squared. Okay. All right, so we've got a couple more examples. We're going to look at one more rhombus and one more kite. And so in this one right here, we know that the side lengths are 8 inches. Hold on one second. All right, and so I kind of gave you this hint here. So this is a rhombus. We know all of these are 8, and we know that one of the diagonals is 10 inches. Oops. So when you're trying to find the length of that other diagonal, obviously we have to start by drawing it in first. Okay, and then we have to recall all the properties of a rhombus. So we know that the diagonals are perpendicular. We also know that they bisect each other. So if we are given that the whole length is 10, we can cut that in half to get 5. And so now I can use the Pythagorean theorem to find that piece. And then we'll multiply it by 2 to get the length of the whole thing. All right, so I know that if I'm going to use a squared plus b squared equals c squared, I don't know this, so I'll call that x. So x plus 5 squared equals 8 squared. 8 squared minus 5 squared is going to be 39.
5 squared is going to be 39.
And then I'll solve by taking the square root of each side. If I go back to that list of perfect squares, there's not one that goes in the 39 as a prime number. So we'll just leave it as the square root of 39. And so that means that the length of the other diagonal is going to be twice that. So 2 times the square root of 39.
Times the square root of 39.
So now when I go to find the area,
times 10
times 2 radical 39. And then we'll multiply our like parts together. So 1 half times 10 times 2 is going to be 10. And then we'll just tack on that radical 39.
And then we'll just tack on that radical 39.
Our units will be inches squared.
Our units will be inches squared.
All right, last one here.
All right,
we know that this is a kite because the diagonals are not bisecting each other. This diagonal is being bisected, but these two pieces have different lengths. And so we do not, it can't be a rhombus. Obviously it can't be more like a kite, and you guys know, obviously never to go by how things look, you guys know. And so if I try to figure out if I know the lengths of the two diagonals, if I don't, then I would use the Pythagorean theorem.
If I don't, then I would use the
4 meters is pointing right here. So that means this whole diagonal is going to be 15.
So that means this whole
diagonal is going to be 12. So luckily I don't have any extra work to do.
So luckily I don't have
So
any
my
extra
area
work to
is
do.
just going to be 1/2
So my area
times
is just going to be 1
times
half
12
times 15
and when I
times
type
12.
that out in,
And when I type that out in,
I get 90 meters
90
squared. Okay.
meters squared.
All right, and so your homework tonight is
All right, and so your homework
10.2
tonight
worksheet that is
the
posted
10.2
on Canvas.
worksheet that is posted
Remember, if you do
on
not have
Canvas.
access to a printer, you're more than welcome to just copy the problems onto
You're
a
more
blank
than
piece of
welcome
paper,
to just
and
copy
then
the problems onto a
upload
blank piece of
your
paper,
work to
and then
Canvas.
upload your